In section 2.5, we're going to solve compound inequalities. So what are you going to learn? You're going to learn how to write and graph compound inequalities. You're going to learn how to solve compound inequalities. And you're going to have to learn how to use inequalities to solve real-life problems. All right, so here's our key concept. So let's look over this. Writing and graphing compound inequalities. Now here's your vocab word. A compound inequality is an inequality formed by joining two inequalities with the word and or. Now something that this does not say, when I like writing this down, and is called a conjunction. Or a compound inequality is called a disjunction. So here's what it means. The graph of a compound inequality with and is the intersection of the graphs. That means where do the graphs overlap? Okay? So if I wanted to do and, so let's just look at this. You don't need to write this down right now. Just look. X is greater than or equal to 2. That means I'd have a closed dot on 2, shade to the right. X is less than 5, open dot on 5, I shade to the left. Now, if I put them together, if I intersect them, that means I want the part of this graph that is greater than and equal to 2 and less than 5. So it's the overlapping region. So if I combine these two graphs here, you'll notice that this part in the middle overlaps. And if that part overlaps, then solid dot on 2, open dot on 5, I shade in the middle. Those two are the solutions that make both these inequalities true. And I can write it like that. Now, you only can write compound inequalities like that. 2, and we did this part last year, 2 is less than or equal to x, which is less than 5. Now, when I do an or problem, that's called the union, where I try to find the union of the graphs. The graph shows numbers that are on either one or both. So if I graph this, y is less than or equal to negative 2. Y is greater than 1. Now I want to know the part of the graph that's one or the other, or both. Well, here's left, here's right, I just combine them. So let's say that this was an or problem. If I just put these two lines together, what would be one, the other, or both? It'd be everything. If this was an or problem, this would be all real numbers. If this was an and problem, what part of these two graphs overlap? None of them. So if this was an and problem, this would be empty set, no solution. So in example 1, we're going to write each of these as an inequality, and then we're going to graph them. So in A, a number x is greater than negative 8 and less than or equal to positive 4. Well, that means it's between. So x is greater than negative 8. And means I can do this. X is less than or equal to 4. If I graph this, that means negative 8 is not a solution. Open circle. So let's count by twos. Negative 6, negative 4, negative 2, 0, 2, 4. This can be equal to 4 since it says equal to. And I'd shade in between. B. Now, you can solve a compound inequality by solving two inequalities separately. When a compound inequality is with and, it's written as just one inequality. So you can actually solve the one inequality by performing the same operation on each expression. So it looks like this. You can pause the video and try to do this yourself if you'd like. But in A, we want to solve and graph this. Negative 4 is less than x minus 2 is less than 3. I want to get the x by itself, so I just add 2 to all three parts. Negative 2 is less than x is less than 5. -2, -1, 0, 1, 2, 3, 4, 5. Open dots on each. And I would shade everything in the middle since it has to be greater than -2 and less than 5. The next one, I'm going to subtract 1 from each part. That gives me -4 is less than -2x is less than or equal to 8. I now divide everything by -2. Well, if I divide everything by -2, this is going to be fun. This gives me 2. This gives me x. This gives me -4. I have to reverse the inequality symbols, and then you must always write this as the smallest integer first, and they must be less thans or less than or equal to's. They must look like this. All I did was just rewrite it. I didn't switch anything, I just rewrote it. If you graph this, -4, close dot, -2, 0, 2, open dot, I shade in the middle. Example 3. We're now solving an OR problem. All you do is just solve each one separately. So this is easy, 3y, I add 8 to both sides. That gives me 3y is less than -3. I divide by 3, I get y is less than -1. Or, if I add 1, I get 2y is greater than 6. Divide by 2, y is greater than 3. So this is the OR problem. -1, 0, 1, 2, 3. Open dot on -1 since it's not a solution, and less than means I shade to the left. Open dot on 3, and since it's greater than, I shade to the right. And there's my answer. Example 4, our real-life problem. Electrical devices should operate effectively within a specified temperature range. Outside the temperature range, the device may fail. So if we just look down here, you'll see that this, it looks like an iPhone, it has to be between 0 degrees Celsius and 35 degrees Celsius for the operating temperature. So we want to write and solve a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. Well, first off, what do we know? We know that the degrees Celsius, let's change that. The degrees Celsius has to be between 0 degrees and 35 degrees. Now, it says that it can go from 0 degrees Celsius to 35 degrees Celsius. So that means it could be equal to both 0 and 35 degrees. But the problem is we don't want Celsius. We want Fahrenheit. So we have to write in the conversion formula. Now you may remember that the conversion formula is Celsius equals 5/9 multiplied by F minus 32. So if Celsius equals this, I have to plug this in. So I'm going to write 5/9 multiplied by F minus 32 is less than or equal to 35. So now I have to solve this problem. So the first thing I'm going to do is multiply everything by 9. Now you could also multiply everything by 9/5. So if I multiply everything by 9, I get 0 is less than or equal to 5 multiplied by 5 minus 32 is less than or equal to 315. I'm going to now distribute, or you could just divide everything by 5. I'm going to divide everything by 5. I still get 0 is less than or equal to F minus 32 is less than or equal to 63. I now add 32 to all three parts. So that'd be 32 is less than or equal to Fahrenheit, less than or equal to 95. So what does that mean? That means the operating temperature is 32 degrees Fahrenheit to 95 degrees Fahrenheit. That's part A. Part B says, describe one situation in which the surrounding temperature could be the operating range and one in which could be above. Now you can write this down on your own, but give me a situation in which the temperature could be below 32 degrees, the surrounding temperature. That means like outside. You could say a cold winter. And one where it could be above. You could say I'm just completely making this up, in the Sahara Desert. There you go.